Compound interest. The best way to think about compound interest is that you are earning interest on your interest. If you think back to the simple interest questions that we were doing, we were basically earning the same amount of interest all the time. So the interest was just based on the original principal. Looking at this diagram here, it gives you a fairly good indication of what's happening. So on $250, the interest was $25. And so then in the second year, rather than the principal being gauged on the 250, it's now gauged on the $275. And then in the third year, it is that 275 plus the interest that it's earned. So you can see that we are increasing the amount of interest every year. The compound interest formula is a little bit more involved than the simple interest one. And if you can remember back with simple interest, we were looking for I. With the compound interest formula, we are looking for A, which is the final amount. So that would be the principal plus the interest. Again, it's in dollars. P is pretty similar to simple interest. It stands for principal and it is in dollars. R is the interest rate per annum. Again, fairly similar to simple interest. We'll jump down to T here because that's the same as well. T is the number of years. It's this N that is very different. So the way I like to think of N is the number of times per year that you get interest, so that your interest is compounded, and that will help us work out the overall amount that we earn. If it was a case that we wanted to work out the interest, then once we've got our answer, we just need to take the principal away from that, and that will give us the interest for that period of time. So we're looking for the amount of money accumulated after 3 years if $2,000 is invested at an interest rate of 8% per annum, and we're told that the interest is compounded. So it is compound interest. Now it's compounded annually in the first one. So how many times a year do I earn interest? Well, if it's compounded annually, I'm only going to earn interest once a year. So my N straight away is equal to 1. So I always like to work out my N so that I know what I'm up to. So then the next bit here, let's write out all of the information that we've got. And we're looking for the money accumulated. So we want A, that's what they're looking for. And we're told that T is equal to 3 years. We're also told that $2,000 is invested, so P is equal to 2,000. And what else do we know? We know that R is equal to 8% per annum. So our rule here is A equals P outside of 1 plus R on N over 100 to the power of NT. So when I substitute in my values for this one, I'm going to get, well, A is what I'm looking for. All right, P is 2,000 outside of 1 plus. Now my R was 8 and N is equal to 1 over 100 to the power of 1 times 3. I would be using solve here on my calculator. So solve x equals 2,000. 1 plus, and that's just 8 over 100 to the power of 3 comma x. All right, put that into your calculator, and what do you get? $2,519. Now remember, that's the total amount in your account after the 3 years. The interest there would be only the $519 because you started with $2,000. So in the next bit, interest is compounded quarterly, which means that we're getting interest every quarter or 4 times a year, which means that N is equal to 4. Now, has anything else changed? Well, not really. We're still looking for A T is still for 3 years. The principal, it's still on $2,000, and our interest rate is 8%. So back into your rule again, A equal to P outside of 1 plus R on N over 100 to the power of NT. Now what does that look like for this one? Well, you've got A that you're looking for again. So the only thing that's going to change on your calculator, if you like, is the N value. Rather than being 1, it's going to be 4. So if I was putting that into my calculator, I would get solve. And again, I'm looking for the A, so it's X equals, P is 2,000, 1 plus, now R is still 8, but in this case it's over 4 over 100 to the power of, now N is 4 times 3, and it's comma X. So you can see that because our principal is staying, our rate's staying the same, the number of years stays the same. The only thing that's changing is that you are compounding your money 4 times a year rather than 1 time a year. And what does that end up being? So we end up with A equal to $2,536.48. Look, a little bit more, isn't it? And so therefore, if I wanted to work out the interest, because that's how much is in my account, remember my interest is equal to A minus P. In this case, it is 2,536.48 minus 2,000. And of course, I'm left with $536.48. So that's how much interest. So if I compound 4 times a year rather than 1 time a year, I end up with a little bit more interest. Let's see if that holds true now for monthly. Now monthly means that I'm going to earn interest every month. How many months are there in a year? How many times am I going to earn it? 12. So my N is equal to 12. And nothing else has changed. A is the same. Well, A is what I'm looking for really. T is 3, P is 2,000. Okay, and so this is still in your calculator. All you have to do is change the N value of 4 to 12 now. So A is equal to P outside of 1 plus R on N over 100 to the power of N times T. And so putting it into my calculator, which should be still there from the last question I've worked out, I'm going to put my N value as 12. So I've got 8 over 12 over 100, and N is 12 times 3. Okay, again that's in your calculator, so it's not very hard to do. And this time I get A is equal to $2,540.47. So what is the interest that I've earned there? Well, again, interest is equal to $2,540.47. Take away the principal, and I'm left with $540.47. So again, just a little bit more than if we were to earn interest quarterly. So that should suggest to you that the more often your interest is compounded, then the more interest you will get. And it goes the same way in terms of paying off a loan. Sometimes people will pay exactly the same amount, but they'll pay their repayments for their mortgage fortnightly rather than monthly, and that chips away just a little bit more of their loan, and therefore they're going to pay it more quickly and therefore own their house faster. Okay, this following activity is best done on your calculator, and we will go through it in class, but this is the way we should set up our table. So we're using our lists and spreadsheets like usual, and we set up time and amount, but in this particular case we're using this middle part of our lists and spreadsheets where you enter a rule, and we haven't really done that much. We did have a look at it when we were looking at simple interest. Now, what does our rule look like? Well, remember, set up a table to enable the amount. So we're looking for A, and we know here that P is equal to 2,000. What else do we know from this? We know that it's invested at a rate of 8%, and it's compounded yearly because we're going up in years. So we know that N is equal to 1. So if I put that into my rule, what does it look like? A is equal to, remember the rule is this, 1 plus R on N over 100 to the power of NT. So 2,000, 1 plus 8 over 1 over 100 to the power of 1. Now be careful. In our rule, it's times by t, but we have to use exactly the same words that we've used in our spreadsheet when we're putting it into our spreadsheet. So this is what it should look like when you put it into your spreadsheet. Once you go into this grey area here, it'll come up with amount equals. And what does it equal? Well, the rule was, we've just worked it out, 2,000 times, okay, or times your bracket, 1 plus, okay, 8 divided by 100, or 8 over 100 to the power of, now remember to the power of looks like that on our calculator, 1 times time. Now we didn't use t, we used time, so that has to go in here as well, to the power of time. And when you put that into your calculator and press enter, you should get lots of different values. Are you getting these values? Fill in this last one for me. So you can see there that as the years go up every year, and remember we are only accruing annually at this stage, that the actual amount in your account is also increasing. And we've talked about that before. The question says use the table to determine the value of the loan after 3 years and the amount of interest earned. Well, we can see from our table that after 3 years, the amount in our account is $2,519.42. And therefore, if we want to work out how much interest we've earned, we take that away from, well, we take 2,000, the initial principal, away from that. And so we calculate that we have $519.42 in interest after 3 years. Have a look at the graph there, okay, because this is number 3. It asks us to plot the graph. That was number 2. To plot the graph, you can see that we're no longer dealing with a straight line, and that makes sense because it's not a constant amount of interest that we're going up in. We're slowly increasing all the time. So we do have an upward curve for our compound interest graph.